Hello everyone, this is Group 5 and today we'll be presenting on credit risk management using machine learning and artificial intelligence. Next. First, we'll share more on why we should use machine learning and artificial intelligence on credit risk management, the data set, the AI model configuration and analysis, business solution, evaluation, the conclusion, and further studies. Next. Interest income contributes to a huge part of a retail bank's profit, as the bank's business model is earning the interest margin between the interest they pay for deposits and the interest they charge for loans. The biggest risk faced when giving out a loan is credit risk, which is the uncertainty of external parties to fulfill contractual obligations resulting in possible loss for the institution. In this case, it is the borrowers defaulting on loans, resulting in the bank not being able to recover their capital plus losing out on the supposed interest income they could have made. It is therefore important for banks to anticipate and try to manage credit risk in advance to minimize the possible impact on business. Next, please. Traditional methods of risk analysis, such as examining each customer's portfolio or using a fixed set of formulas considering only certain risk factor, is manual and incapable of an all-rounded assessment of all the available attributes that the bank has access to. Next slide. Machine learning and artificial intelligence could be the solution to this, as it develops models to predict and recognize patterns with minimal human intervention. Analysis on large data sets determines pattern and construct meaningful recommendations, as AI and machine learning can uncover subtle relationships, capture various non-linearities, and process unstructured data without the need for assumed theoretical models, and prediction is purely based on the data provided. Next slide. With the significant increase in speed, data, and attributes considered in the analysis, the accuracy for credit risk prediction will be improved, and recommendations provided by the model for different groups of customers will be more suitable for the bank when managing credit risk. Next. For this project, we'll be utilizing some data visualization options to allow users to better understand what attributes will affect the loan defaulting the most, and exploring and comparing various machine learning models on Python using our data set in hopes to find the model with the highest accuracy in predicting the risk of customer defaulting their loan. Now, Hong Wei will be sharing more on the data set used.
Thank you, Cindy. Yep, so now we'll take a look at the data source, description, and pre-processing done on the data set. So the data set utilized for the modeling was sourced from Kaggle, and it's actually called the credit risk data set. So the data set was provided in a CSV format, and it contains 32,851 rows and 12 columns. So out of the 12 columns, 11 of them are the feature variables, and the remaining one is the target variable. So for the data pre-processing, we removed rows with missing values as well as unreasonable values. So for missing values, we found that in the person employment length as well as the loan interest rate variables, there were missing values. So these data points were actually removed from the data set. In addition, we also discovered that in the person age and the person employment length variables, there were unreasonable values of more than 100 years. So these data points with unrealistic values were also removed from the data set. Next, please. Yep, so moving on to the data scaling and encoding. So firstly, for the data scaling, due to the differing magnitude and scales of the columns in the data set, we utilize a z-score normalization technique on numerical data such as the person income, loan amount, and loan interest rate. So this is actually to prevent the dominance of any single feature variable in any distance computation in the machine learning models. Next, for the data encoding, we actually utilize two encoding techniques. So the first one will be the one-hot encoding. So this was done on the categorical data such as the person home ownership with various categories. So this was actually done to allow the machine learning models to better understand this type of field. And then next, we have the ordinal encoding. So this was done on ordinal data such as the loan grade data. And this is done because of the ordinal nature of the data. So for example, an A grade in the loan grade is actually better than the E grade. So we actually assign an A grade with a value of 1, a B grade with a value of 2, all the way to an E grade with a value of 7 to allow the machine learning model to understand the importance of this field. So moving on, next slide. Yeah, moving on to the data visualization piece. Firstly, we plotted the correlation matrix. So it illustrates the correlation coefficients for the various variables. And we noted that there was a high correlation of 0.88 between the person age and person credit history length. So this is reasonable, as the longer a person has lived, the longer the credit history he or she has with the credit bureau. Next, please. Yep, so for the next visualization, we plotted the number of defaults and non-defaults by age. And we observed that majority of borrowers are actually in the age range of 21 to 30. And this is expected because people in this age range are the people that need money the most. So it's more likely that they will actually borrow from the bank. And from this graph, we also observed that the ratio of defaulters versus non-defaulters were relatively constant over age. So this means that there wasn't any particular age group that were more likely to default on their loans. So that's all for the data visualization piece. And next, I will hand over the time to Singa to talk more about the machine learning models and configuration.
Thank you, Hongwei. Okay, so for the AI model configuration and analysis, grid search was actually used to actually optimize the parameters so that the accuracy can be actually adjusted further to actually give a better credit risk prediction. So the 4 AI model that were used were actually, the first one would be logistic regression, followed by decision tree. The third one would be random forest, and the fourth one would be multi-layer perceptron. So as you can see, for the logistic regression, right, the accuracy predicted was 80.84 before optimization. And for the decision tree, the accuracy predicted was actually 89.38 before optimization. Next slide. So for the random forest, right, the accuracy predicted was actually 92.74 before optimization. And for the multi-layer perceptron, 88.13 accuracy was predicted before optimization. So, okay, next slide. So here we have the accuracy comparison of before and after optimization. So as you can see that after optimization of the 4 AI models, the accuracy has increased. And one prominent thing to note is that random forest would be the ideal choice for our data set, because it has actually achieved accuracy of 92.74 before and 94.82 accuracy after optimization. So now I'll pass my time to Kelvin to actually talk about the solutions.
Okay, so next we will take a look. We'll discuss our business solutions and the advantages of AI and the benefits of AI. For the advantages of AI, it allows banks to plan strategies ahead before issuing credit loans to customers. And it also allows the bank to measure and predict the risk of potential customers, whether they will default their credits. And it also allows the bank to figure best business for and also determine the level of risk. For the benefits of AI, there are 5 of them. The first one is risk-free scoring. AI credit risk tools can better process a huge amount of data and identify patterns and create as much error-free and risk-free credit risk management as possible. Number two, reduction of credit management time. AI will significantly reduce time to market. Number three, automated process. AI can automate the whole process practically, therefore eliminating human participation in credit risk scoring. Number four, reduction in credit losses. And while AI can predict delinquencies for a year in advance, the only thing there is that you have the right data necessary to build a model. And lastly, accuracy in prediction. AI solutions are intuitive. The more new data sets that we feed into the systems and the more that they analyze, the better they learn, coming up with more accurate predictions. So that's it for benefits of AI. I will hand over to Wong Sim for evaluations, recommendations, and conclusions.
Thank you, Kevin. From the model results covered earlier, we observed that the AI models operate well with a large data set to predict the status of the loan. As our data set is mainly cross-sectional in nature, AI here is mainly to automate credit decisioning within the initial stage of a customer's life cycle. So next, in order to make our AI models more robust, longitudinal data can be gathered as well. This is especially important as many customers have long-term banking relationships with financial institutions. Having both cross-sectional and longitudinal data in the AI analytics, it will add value to the credit risk management process across the customer's life cycles. Next, we will move on to future studies. Firstly, we have seen the high accuracy of predictions with AI models. However, as the models often have hidden layers of decision-making from the inputs to the outputs, banks may encounter compliance issues due to insufficient evidence of AI-based decisions, and this will negatively affect fairness and risk appetite. Future studies on this issue will focus on the compliance guidelines and principles that banks can follow so as to use AI more fairly without causing any harm to their customers. Secondly, the black box concept behind AI models raises governance issues as well. The lack of transparency in the AI-based algorithms to the users can lead to biased decision-making in the absence of proper AI model governance and strong internal communication systems. Future studies on this issue will focus on how companies can establish strong business support and effective internal approval methodologies that aim to enhance transparency of credit decision-making and AI governance. Lastly, as the credit risk is the central risk that banks manage and face, it is essential to ensure the data quality and credibility gathered. Data obtained from questionable and non-credible sources will definitely result in false and unreliable outputs. As a result, banks that incorporate AI-based credit decision making may face tremendous financial losses in the future when their customers default on the loans. Future studies on this issue will focus on how financial institutions can overcome this problem in data gathering and thus improve data quality and credibility. Therefore, we can foresee that once the obstacles are overcome to a large extent, banks can leverage on AI more extensively in the future to automate their credit risk management process. We have come to the end of our presentation. Thank you for listening.